STV is the signal of the beginning of the vertical scanning of the frame. CPV is the clock signal which allows to synchronize the output of the data of each flip-flop in a successive way. On datasheets, there are different ways to specify the direction of operation of bidirectional registers. For example, for STV, which is the abbreviation of vertical start, we add a number to STV. STV1 will indicate the direction of the scan from left to right, and STV2 for a scan in the opposite direction. We can find another denomination like SVIO or SVOI. SVOI is the abbreviation for start vertical input-output, i.e. a scan from left to right, and SVOI is the start vertical output input for a scan from right to left. Another term, DO, for data input-output, or DOI, for data output-input. On the datasheet, we can find the inscription RL, which is an abbreviation of right and left. The gate drivers used in LCD have the characteristic of having a bidirectional shift register. Depending on the configuration of the RL pins, the scan will be different. For example, if the RL pins are in high mode, the scanning direction will be top to bottom. Or written in another way as shift right. If RL is in low mode, the lines will be scanned in the opposite direction from bottom to top. This is why an image can be inverted depending on the setting of the RL pins. Here is an example with 3 driver gates in series. The direction of the scan is determined by the configuration of some pins. On the datasheet, it is necessary to look for the inscriptions RL for right-left and, or, the inscription UD for up-down. In this example, the direction of the scan will be either from STV1 to STV3, i.e. from top to bottom. Or in the opposite direction, from bottom to top, i.e. from STV3 to STV1. This animation shows the appearance of the image according to the direction of the scan. In the conventional direction, the scan is from left to right and from top to bottom. This scanning direction is determined by the configuration of the pins UD for up-down and RL for right-left. In all, there are 4 display possibilities depending on the combination of the up or down state of the different pins, but there is only one state that allows for a correct display, i.e. in the right direction. When troubleshooting an LCD TV, for example when installing new software, the picture can be reversed. Without intervening on the hardware, it is possible to correct this problem by intervening on the software of the television using the remote control. To do this, you need to access the service menu and then, depending on the model of the television, find the mirror mode entry. By changing the value from on to off or the other way around, the image will be put back in the right direction. For other brands, you must first find MRT option and then find the HV flip function, which allows you to control the direction of the display. In the animation that we have seen before with the shift register lacks other stratum or layer of material that composes the gate driver and that will allow to supply the TFT in panel with VGH and VGL voltage. We recall that the TFT transistors do not work with a digital signal and need an analog voltage. VGH and VGL are the analog voltages that allow to activate or deactivate all the transistors putted on the same line. VGH and VGL are provided by the TCON board thanks to a DC to DC converter. VGH is the acronym of voltage gate high. It is the voltage of starting of the TFT transistors from where the abbreviation V on is sometimes used. VGL is the acronym for voltage gate low. It has a negative value and is used to turn off the TFTs, hence the other name V off. The names and inscriptions of VGL and VGH vary from one TCON board to another. We can find V on and V off written with or without an E at the end. Sometimes is added G in front of the word off or on. G corresponding to the first letter of the word gate. Other inscriptions to designate the VGH and the VGL, we can find VEE, corresponding to VGL or VEEG. VGH can be written VGG or VDDG. We saw previously in the block diagram of the gate driver the existence of a logic controller circuit. The latter is constituted by an assembly of several logic gates. At the electronic level, the various logic gates are composed of transistors. For the understanding of the subject, a short reminder on some logic gates is necessary. The YES gate is the most basic logic gate. It is also known as a buffer. Its function is to simply copy the state of the input bit to the output bit. So if the input bit has the value 0, then the output will also have the value 0. If the input is equal to 1, the output will also be equal to 1. In a NOT gate, the value of the output bit is the inverse of the input bit. On the diagrams, to differentiate this gate from the YES gate, has been added a small circle in front of the triangle. For the result, if the input is equal to 0, the output will be equal to 1. If the input is equal to 1, the output will be equal to 0. In a logic gate AND, there are two inputs and only one output. The output value will be equal to 1 only if the two input bits are equal to 1. In other cases, the output will be equal to 0. The inverse of the AND function is the NOT AND gate, abbreviated to NAND. This gate corresponds in reality to an AND gate followed by a NOT gate. This allows to find the inverse of the AND gate. The logic circuit of the gate driver is made as follows. According to the number of shift registers are placed in series as many NAND logic gates. There are two successive layers of interconnected NAND gates. The first series of NAND gates is under the control of the OE digital signal, whose role will be seen later in this video. In front of the output of the OE signal is placed another logic gate NOT, which will invert the signal. On the second line, all the NAND gates are under the direct control of a digital signal called XAO, the meaning of which will also be explained later on. For a normal operation of an LCD screen, the OE signal is at a low level or 0 and XAO is at a high level or 1. At the first sight of this diagram, we can wonder why to have complicated the circuit to finally find at the output of the NAND gates the same values as at the output of the shift registers. There is a reason for this which will be developed in a moment. Let's continue with another element of the gate driver block diagram, which is an electronic circuit called a level shifter or voltage level translator. The principle of this component is to make compatible circuits working with different logic levels. For example, a first circuit noted 1 provides a digital signal of 3.3 volts. The second circuit noted 2 works only with a logic level of 5 volts. To make the two circuits compatible, the level shifter will raise the voltage from 3.3 volts to 5 volts. The reverse operation is possible. The clock signal CPV of the shift register is transformed by the level shifter into CKV. It is the same clock signal but with a higher digital voltage value. CKV is an abbreviation for vertical clock, the clock that controls the vertical scan. The level shifter chip can be integrated into the gate drive chip, or integrated into the TCON microprocessor. It can also be found as a separate chip on the TCON board. To locate it on the TCON board, look for markings such as CPV, CKV, STV or VST, which mean the same thing. Here is an example of a level shifter chip on this TCON board. At the input of the chip you will find the terms STV and CPV, there is also the term OE. At the output of the level shifter, the conductive tracks are engraved on the back of the board and then reappear at the test points which are directed to the connector of the screen. We can see the term CKV, but there are also other terms such as CKVB and STVP. Note that on this board the VGH and VGL are labeled V on and V off respectively. The level shifter transforms CPV into CKV. The STV signal is transformed into STVP. CKV and STVP are the same signals as CPV and STV respectively, but CKV and STVP have a higher voltage value. From this level shifter will come another clock signal which is the CKVB. This signal is the inverse of CKV. It is also used to control the gate of TFT transistors. The B that has been added to CKV comes from the word bar because the inverse of a value is mathematically noted by a bar above the letter that represents it. Here is a chronogram that represents the correspondence between CPV or CKV and the output signal of the gate driver. At the rising edge of the first clock pulse, the first output of the gate driver called G1 is activated. Note that the activation time of a line is equal to the duration of a clock pulse, which includes a high clock level and a low clock level. At the second pulse of the clock still on its rising edge, the second output of the gate driver G2 is activated while the previous output G1 is stopped. The same process will take place successively until all the gate driver outputs are scanned. The disadvantage of this process is that there is a certain waiting time between the activation of each